This is going to be an introduction to the class on modeling and simulation. Mainly, it's going to be a class about modeling, and I'll just sort of give a brief, maybe 10 to 12 minute introduction. Okay, so we'll call this a journey into modeling. And I've got a picture of Lord Kelvin's tide machine. This is from the 19th century, late 19th century, and essentially it was a machine, a computer, which is analog. It's all totally mechanical in order to predict tides. This is just a little bit more on it. One thing to note that during this presentation you can click on a lot of these figures and it will go to the original source on where the figure came from, and you can find out more information about the slide. One thing to notice is that even though electric motors had been invented when this tide machine was created, a hand crank is, it's just human powered. So there was no, this is no electric motor on this. It is in a computer to do tide prediction. Another interesting thing is it was used in World War I and World War II. For instance, in World War II, during D-Day, which is to say the time when the Allies went into Normandy, did the Normandy invasion, the tide machine was used as a computer back then in order to do tide calculations. So just a historical interest. Okay, what's a model? A model is a simplified representation of something. So it's really that simple. Models are created using different media. I could create a model with toothpicks. I could create a model with Lego blocks. I could create a model on the computer. It could be using diagrams, or it could be using text, typography. And so models are associated with different media. A model is really a language construct. That's a way to think about it. It is it's like French, Chinese, English. It's essentially a construct that has a grammar associated with it. When you think of models like that, it brings models, I think, and language closer together. So the way we're going to be approaching modeling is a little different than you might find in other classes. We begin by perceiving the world, so through our senses. We then reflect on that perception, and that reflection might involve making connections with other things. And finally, we do research, and in order to complete our knowledge about something. We perceive something, but it may not be complete. We need to go do our homework and find out, how we can model the thing that we're talking about in more detail. So an example that we're going to be using is fire hydrant, just through some of these slides. And I think the first thing to say about modeling is that the simplest kinds of models you already know. You've already done this. You may not have thought about them as models, but a sketch is a simplified representation of a fire hydrant in this particular case. It's definitely simplified. It's not as complicated as a fire hydrant. It's faster to produce. And so just drawing something, sketching something, or painting it, or indeed sculpting it, are sort of fundamental aspects of making that is modeling. Also, writing is a form of modeling, which you do, not only in English, but perhaps your native language, if that's not English. And so these are sort of a couple different types of models that you already know. And thinking about them as modeling, I think, makes sense. If we had a real fire hydrant, well, we sketch it, and that representation helps us think about the model and the fire hydrant. And likewise, we can also use writing in order to describe some activity around a fire hydrant. So the first step is perceiving, and we have three types of models that are covered in the class. One is based on knowledge, And this could be something as simple as a data structure, but it might be something more complicated like a semantic net or some form of formal logic. These are model types you learn about in the class when you're trying to model knowledge about a thing, like a fire hydrant. A space-based model is something that looks like the fire hydrant. So you could think of the sketch as being kind of spatial in the sense that it looks a bit like the thing you're modeling. And also we could think of time. Now time every object really has time associated with it. And it could be everything from, the decades that pass and the rusting of the fire hydrant or something like that. That's something that occurs over time. But of course, the more obvious thing that comes to mind is when the fire department gets out, opens up one of these valves because there's a fire in the neighborhood, and they put it out. So that's a process. It's a fairly complicated process which needs to be modeled and simulated. So a couple of other things to think about modeling is, do we model the whole scene? I mean, that picture right here was a model of a fire hydrant, but there's some plants next to it. This should be a valve cover right here, but then there's the bushes and dirt and so on. So all this stuff really is in the background and yet could be modeled as well. Or do we just model one of the objects, like the fire hydrant? And we just forget the dirt, we forget the bushes, we're kind of going to ignore that. So that points to another aspect of modeling, is that modeling throws away information. It abstracts what you're trying to model and often discards everything else. But models can also be something related to the scene. So the scene contains a fire hydrant, but what's related to a fire hydrant? Well, lots of things. Fire hydrants are actually have historical connections. Like this is a historical connection. The Great Fire of London, which happened in the year 1665 and caused lots of changes to building codes within the city of London. But there have been many fires throughout history, and they're related in a kind of semantic way to the fire hydrant, right? Because the fire hydrant is constructed to be able to put fires out, but of course that links to the idea of fire and the idea of uncontrolled fire, which brings us to the Great Fire of London. So this is a connection. This could simply be modeled when you're looking at the fire hydrant. You imagine that there could be other things like fires that could be modeled, and they're related to the fire hydrant. Another thing is, as a kid, you might have, especially if you were in the city, you may have fire hydrant was unlocked, turned, and the water came out, and you got a little bit wet in the hot summer. So that's something that the fire hydrant reminds you of, and when you go modeling, you may want to model that scene because it's a pleasant scene and you remember it from your childhood. So one of the things you do in modeling is you start doing anatomy on it. We find out the components of the fire hydrant, which are right here. The fire hydrant's just a component of a very large network. And that network essentially is our water network, which goes through cities, goes through neighborhoods, goes through buildings. And so there's a gigantic network of pipes and valves, which finally connect to this terminus right here, which is a fire hydrant. You can have 3D models. This is a kind of a space-based model. People have made 3D models of fire hydrants. You can buy them. There are some that are free. If you click on this picture, you'll get to. Sorry, you may click. Actually, it may be the. It's either on the picture you click on or the text up here. But you'll see some examples of three-dimensional models. When people talk about model, sometimes they talk about a spatial model, a geometric model, something that preserves the shape and look of a thing. But you also are going to come across in the class knowledge-based models that are, in this particular case, this is a model of something that's related to the fire hydrant, the fire truck. And you can see the fire truck is the main concept, which is at the center. And then there are these spokes that come out, these relations that connect to other entities. And so there's a whole host of different types of models that are related to modeling knowledge. This could be seen as a sort of dynamic model that has, it has actually, these are sort of sprayers right here. When you got hoses and they're connected to the model, you might use a model like this. And the model in this case is this sort of network with black circles and arrows and pictures of valves. And there's actually some pictures of flow rate, it looks like, right here. So this black network is a model that might be used on how the water flows into the fire hydrant and then out through the hoses. And there are things called mathematical models, and just to jump to the chase, look at this thing right down here. Whoops, sorry about that, last slide. This is a very simple mathematical model of the water pressure on a tank of water. Again, a tank of water is sort of related because the fire hydrant is attached to the water mains. The water mains are going to be carrying potable water, drinkable water. And another thing attached to the water mains are tanks, which hold water as a kind of capacitor of water. And you find them a lot in cities like New York City, Brooklyn, and so on. And there's a nice story to go along with that if you just click on this.